Hi everyone. Today's Tech Talk, DevOps Edition, is focused on why to use OpenTelemetry processors to change collected backend data. I'm Johnathan Campos, a Senior Product Marketing Manager focused on observability, and I'm excited today to be here with you on today's Tech Talk. Let's get started. For today's agenda, we have a little bit about observability and OpenTelemetry. We'll go into what are processors and how they're implemented, and then we have a small demo on how to implement processors with the OpenTelemetry collector to redact secure data, and then we'll go over some additional resources to help you on your Splunk journey. So I first want to get started with answering the question of why observability. And many of you probably have observability already in your environments or clearly understand what observability is, but to paint a picture on why we want to use processors, I want to re-answer this question for everyone. Observability really allows us to monitor, manage, and really get a clear understanding of what our microservices are doing. See, microservices create complex interactions, and these failures don't exactly really repeat, and we tend to have a really hard time debugging multi-tenancy environments, and it just can become very, very painful. So really, general traditional monitoring is just not enough for us. So when we look at what observability does, it really just answers the questions about our systems. Let's take a look at a question that we'll answer. What characteristics did the queries that timed out at 500 milliseconds share in common? Was it services? Was it a version? Was it a browser plugin? What really happened for this delay? We have to factor in that latency is probably the new downtime that we're really fighting. And as competition increases, as customers have so many options to choose from, we have to factor in that slow sites, slow applications are just not acceptable for our customers anymore. And then, of course, within observability, instrumentation produces data, and we have to have an easy way to produce that data as well as consume that data and understand that data. And we have to have solutions that allow us to query and get the answers that we're looking for. And this is what observability is going to do for us. Now, when we take a look at telemetry, telemetry aids observability. And the telemetry data isn't observability itself. It's the actual instrumentation of our application. It's how we get telemetry. And telemetry data includes traces, logs, and metrics. And these particular data points, or telemetry, allows us to clearly understand what really is going on. It's not, hey, there's a service acting up, or hey, there's a server down, let's take a look into it. This is more getting the answer right away so that it makes your troubleshooting much, much easier when trying to find that needle in a haystack. Now, what can we use to really gather that telemetry? What can we use to make this happen? And that happens to be OpenTelemetry. When we take a look at OpenTelemetry, it is a set of APIs, SDKs, toolings, and integrations that are designed for the creation and management of telemetry, like we mentioned before, for traces, metrics, and logs. And the really OpenTelemetry standard is really helping a lot of organizations all around. And how do we really collect that telemetry? Well, this is where the OpenTelemetry collector comes in. And again, the beautiful thing behind the OpenTelemetry collector, it is that it's a vendor agnostic implementation. So your data is yours. You get to choose where your data is sent, and your data is your data. Now, there are two ways we can instrument an application using the OpenTelemetry collector: manual instrumentation and auto instrumentation. Now, let's take a look at quickly what the differences are between manual versus auto instrumentation. Manual instrumentation means that developers are required to change and add to their application code to start and finish a span, and define payloads by use of the client libraries. While manual instrumentation may help in better understanding what we expect our application to do, what is concerning is what we forget to do and not see. Now, with auto instrumentation, or automatic instrumentation, this requires no code changes at all. And with auto instrumentation, we can leverage an intelligent agent like the OpenTelemetry collector that attaches to the running application and extracts tracing data for a quick way to begin gathering metrics. Now, when we look at the OpenTelemetry collector, we can see that in order for it to start collecting data, we leverage that OpenTelemetry library and we send this data to the OpenTelemetry collector. And this sends all of the data to a backend like Splunk. And then here you can view and understand exactly what your application is doing. Now, the OpenTelemetry collector components include receivers, processors, exporters, and extensions. Receivers are really about how you're going to get that data in, all that telemetry data, and receivers can be push or pull based. Processors, which we're really going to focus on here, are what we do with received data. Exporters are where we send received data, and exporters can also be push or pull based. And extensions, which provide capabilities on top of the primary function of the collector. Extensions include things like a health checker, just to see if your collector is up and running. Now let's take a look at what a processor can do with received data. Now, why make use of processors? Well, if we're auto-instrumenting an application, for an example, we may want to focus on our metadata and potentially add or redact metadata so that way we can A, secure that data, or B, better identify where this data is coming from. When we redact data, we want to look at things like potentially customer data that may be secure that we don't want to send to our backend system. Or if we want to add metadata, we may want to look at something like our deployment environment or potentially a version number of our application that we've deployed. Now let's take a look at the OpenTelemetry configuration. Here's an example. You can see that the configuration is broken down into two sections, define and enable. And it's broken down in YAML language, so it's pretty easy to modify. Now when we look at the top, the definition part, we can see that we're defining our receivers, we're also defining our processors, that's in green, and then of course our exporters, which is in teal. Then on the bottom is the enable section, where we would then enable those given defined services, receivers, processors, or exporters, for a given service. And this creates our pipeline. When it comes to this definition, you can see that in yellow, for our traces, we've enabled OTLP as it's been defined above. We've enabled batch for processors, and for exporters, we've enabled the SABM exporter so that we can send all our data to Splunk. Now, when it comes to leveraging processors within the configuration, you can see here that we've added the attributes processor. And it's defined with its given actions to delete a specific key value pair that may contain SSN or a key value pair that may contain user, and we're going to hash that particular user key value pair. We're going to see that in a demo. And on the bottom here, we can see that we've enabled that within our pipeline for our traces. Now let's take a look at a demo of the implementation of processors, where I'll walk everyone through a demo of how to implement processors within the OpenTelemetry configuration. So to better understand the OpenTelemetry configuration, what I'd like to do is demonstrate how we would use processors to omit or redact a given social security number from an end user sent to a backend service using processors. And with that, what we're going to do is we're going to first take a look at the configuration that does not have the attributes processor enabled. You can see we have a definition for receivers where we're sending all information to Zipkin on port 9411. We're exporting to logs. We're not doing anything special, sending anything to any backend service at this point, just for the demonstration. And then we have a definition here for a given processor so that we can remove the social security number from any payload that may be sent to the backend service. Here on the bottom, we've enabled only the receiver Zipkin and only the exporter logging. On the second configuration, we've then enabled that processor attributes, which we can see here. And this is the processor attributes. And this is what the payload looks like. You can see that we have a trace ID, we have a parent ID, we have a kind, we're identifying the name, the timestamp, the service name, and so on. And then as far as the tags are concerned within this given trace, you can see that one of them happens to be a social security number. The other happens to be an email of that given user, the status code, the method, and so on. So to get started, what we're going to first do is we're going to start taking a look at those logs. We can see here that the collector is ready, begin running and processing data. So that looks good. We'll then go ahead and replace the agent config file so that we can reflect the configuration that contains no processor attribute. Again, that's this one right here, no processor attribute. So now that we've done that, we'll go ahead and restart the collector. And we can see that reflected here in the logs. Everything is ready, begin running and processing data. We'll then go ahead and send a post. And we can see that the backend, or in this case, we've stored in the logs, the actual social security number here. So the user email, the HTTP target, and so on and so forth. So everything here is reflected and collected on this given backend service, which in this case is just a logger. We'll then go ahead and replace that configuration file to the one that reflects the actual processor or enables the processor attributes, which we can see here. And we've done that. We'll restart the collector again. And then we'll run that post once again and see that the actual user's social security number has been redacted. So again, this is exactly how we can use the configuration of the OpenTelemetry collector to leverage processors to redact metadata from given payloads that are sent and stored as far as traces are concerned. I really hope you enjoyed that demo. Before we wrap things up, I wanted to quickly share the resources available to you to continue your journey with observability and OpenTelemetry. You will receive these assets in a follow-up email as well as the recording. Don't also forget that we have an incredible community of Splunk users on our community site. You can search the answers section on OpenTelemetry and continue the conversation for this talk within the discussion section called Tech Talks. Here you will find additional resources as well as Splunk ideas, where you can submit new product enhancements or vote for current ideas from other customers. We really appreciate you taking the time out of your schedules to join us today. Be sure to tune back in for future Tech Talks. Now let's open it up for Q&A.